All right, friends, welcome back. In this video, we're going to be starting Chapter 7, taking a look at Section 7.1 of your textbook. And Chapter 7 is all going to be about what a matrix is, or matrices, plural. What these are, basically, are rectangular arrays of numbers, as you can see here. We basically just gave every single number in this matrix a name. We called it A, and then we gave it a subscript of a particular type. We'll talk about what that means here in a second. But what matrices are basically just these arrangements of numbers in these rectangular shapes. And what this allows us to do is, well, to do a number of things, right? So we can go ahead and interpret a matrix as something that stores data. So we can interpret a lot of data very quickly. We're going to see that we're going to be able to use matrices to make some sense out of systems of equations, which is the topic that we just came out of last chapter. So in this video specifically, I just want to give you a brief introduction of what a matrix is and how we can go ahead and do various things to understand matrices a little bit better. And then in the next couple of videos, we're going to talk about operations you can do with matrices. So let's get started with that. So the first thing that we'll want to talk about is what you call the order of a matrix, right? So basically, when you see the word order, I want you to think of the size or the dimensions of the matrix, right? So basically, all we're talking about is if we give you a matrix that we say is this right here, m by n, that's how you would read that. You know, specific examples of this would be like a 2 by 3 matrix or a 4 by 4 matrix or a 7 by 8 matrix or whatever. All we're talking about there is the numbers of rows and columns that the matrix has, right? So if I tell you that we have an m by n matrix, then what that means, of course, is that we have a number of n columns. And you could count up the columns there. You could see that the subscripts go from 1 to 2 to 3, and then all the way over to the right over here to n. So that's going to be n columns. And then we also have a number of m rows. Okay, so n columns and m rows. And you can see that that subscript starts off with a 1, and then 2, and then 3, and then comes all the way down here to m, telling us that that is the mth row, right? And that is very much the way that we interpret these subscripts, right? So we're not going to see these all the time, but they will come up from time to time. And when we do, I just want you to know what you're reading, right? So for example here, it says that entry A23 refers to the entry in the blank row and the blank column, right? Well, remember that it goes rows first and then columns next. So if it says 2 first, then that means it's talking about the number of rows. And so we're going to be looking at the second column. Oh, sorry, not the second column, the second row I meant, but the third column. Okay, and you can see here if I go all the way to the second row and to the third column, there is that entry A sub 23, and there we go, right? So that's just a quick way of being able to reference a quick entry. And you can see all these dots in the matrix, again, because we just kind of wrote this down in the general case where it's just m by n. We don't know what these values m and n are because we're just keeping things general. You'll typically see that we use some dots to refer to the fact that m and n could be extending out to any number of columns or rows. So a couple of particular examples of matrices and just terminology I want you to be familiar with, right? If we ever say a row matrix or a column matrix, then basically these are going to be matrices that are only made up of one row or one column. So these will come up from time to time. Again, you might hear me throw that terminology around. I just want you to know what I'm talking about. And then, of course, the last type of matrix that we'll see here for a while is something called a square matrix, and this is what you think it might be. The basic matrix in a rectangular shape is more of a square shape, right? So we have the same number of rows as we do columns. And so you can see a couple of examples here, right? So it says a square matrix has 2 rows and 2 columns here in the case of this 2 by 2, which would be the dimensions of this, by the way, so get some practice with that. This would be a 2 by 2 matrix. The next one down, that is 3 rows and 3 columns, so that would be a 3 by 3. And again, the way that they're arranged is in more of a square shape, so we call this a square matrix. And then, of course, one more bit of terminology here. When we refer to these rows that go down the diagonal of your square matrix, we call those the main diagonal entries, right? So they call this entry 1, 1 and entry 2, 2 and 3, 3 all the way out to n, n. What we're basically talking about are these entries that go down the main diagonal like this. Sometimes we're going to need to refer to those entries specifically, so it's useful to have a name like the main diagonal entries there, okay? So just a couple of pieces of terminology and just kind of getting used to how we talk about matrices here real quick. What I want to do real quick is just go ahead and get some practice with pointing out what the order of a matrix is, right? So I have a couple of different examples here. It just says determine the order of each matrix, so let's go ahead and do that, right? So in the first case, we just have a matrix that is a 1 by 1 matrix, okay? So that is the order order, so we're just going to go ahead and write that down. That is a 1 row and 1 column matrix. It seems a little bit awkward to just kind of see that one single entry inside the square brackets like that, but that would still be considered to be a matrix. It just has 1 row and 1 column. In the next one over, we see here that we have 1 row. Remember that rows go horizontally, columns go vertically here, so I only have 1 row to speak of, but I have 1, 2, 3, 4 columns here. And so remember that the order of your dimensions here goes rows first, columns next. So this would be a 1 row by 4 column matrix. Okay. The next one over, part C, that is a square matrix. Okay, so that is a 2 by 2. And you can see that all the entries are 0 there. But again, we're just trying to point out the dimensions or the order of this matrix here. So that's a simple 2 by 2. And then, of course, the next one over here we have, let's see here, we've got 1, 2, 3 rows going all the way down. And then we have 1, 2 columns. Okay, so that is going to be a 3 by 2 matrix. Okay, so just remember that the order goes the number of rows first, followed by the number of columns. And of course, matrices are useful for a lot of the different things, but the reason that we're specifically talking about them now, right after Chapter 6, having just talked about systems, is that we can actually use matrices to analyze systems. And we're going to see how we do that as we go throughout the course of Chapter 7 here. But one of the things that you may remember about dealing with these systems with 3 variables in them, or for that matter, any system with 2 variables or whatever, is that the most important parts, the things that we've been working the most with, are these numbers that are in front of the variables, right? So it wasn't so important what the variables were themselves, because we did all of the operations with these numbers in front of the variables, and even these constants over here on the other side. And so one of the ways that we can maybe interpret or work with systems a little bit easier is by eliminating the variables from the problem and just reaching for those coefficients and the constants and putting them in a matrix like this, okay? And so what this is called is an augmented matrix, and you can see the definition here. It's basically a matrix whose entries are the coefficients and constants of a linear system. And so first thing I want you to notice is that your system has equations that are all written here in what we call standard form, okay? So I'll say that here. These are all in standard form. Okay. Again, where the x's are lined up, the y's are lined up, the z's are lined up, et cetera, et cetera. What I want you to notice again is that we are just taking all these coefficients and we are putting them into a matrix as just all of these entries here. And what this is going to allow us to do is it's going to allow us to perform some simpler operations and solve systems in a little bit of an easier way using some techniques that we'll focus on here later in the chapter. The only other thing that I want to point out about these is that where the equal signs are in an augmented matrix, you're typically going to find that we use just a linear set of dots there to just kind of separate the coefficients of the variables from the constants on the other side of the equal sign here. You may see that. Another thing that you may see is people just putting just a straight vertical line right there. Again, just some sort of separator to say that on the left-hand side of it, these are all the coefficients of my variables. On the right-hand side, these are all the constants that all this stuff is equal to. So an augmented matrix is super easy to write out, so let's get some practice with that. So example 2, write the augmented matrix for the system of linear equations below. All we're going to need to do yet again is just point out what those coefficients are and then point out what those constants are and then write them in a matrix. And so on our x's we have 1, 2, and -1. So what I might do to start off my matrix here is just kind of make my first column. I know what those entries are. It's going to be 1, 2, and -1. And then I'm going to follow that up with my coefficients on my y. So that is going to be a +1, a -1, and a +2. So we're going to say that, +1, -1, and +2. Follow that up with the z's, right? So that'll be a +1, a +3, and a -1. So +1, +3, and a -1. And then there goes your equal signs, right? So here's where we would typically want to go ahead and reach for just a straight line of dots right there, just to kind of tell the reader this is where my equal signs were. And then finally we're going to write the constants on the other side of those equal signs here. And so that is going to simply be 2, -1, and 4. And it really is that easy. I'm not trying to trick you. That is our augmented matrix for this system, okay? It's going to be really important that we get used to that skill because later on we're going to have to take systems and solve them using matrices. And so being able to kind of write the augmented matrix from that is really important. And also going the other way around here as well, right? So now we are going the reverse direction. So write the system of linear equations for the augmented matrix. And so here in this first example, again, we see those dots there. We see the numbers on the other side, but we only see that we have 2 columns of them, right? So we have 1, 2 columns. So what that must mean is that this is your x column and this is your y column, and then the numbers that are on the other side of the dots, those must be our constants here. So this is super easy to write out. All we're going to simply have here is 2x minus 1y, or in other words, just minus y, is equal to 3 as our first equation from the first row. And then the second equation will look like negative 9x plus 2y is equal to positive 1. And once I go ahead and write that little curly bracket there, this will go ahead and represent the linear system that goes with that augmented matrix right there, okay? Now, of course, we're going to stick with the convention of sticking with x and y whenever possible. However, we are going to have some more columns and rows, so what we are typically going to do is just go ahead and count the number of columns that we have and then use the next variable in line, right? So here on this next one, you see that I have more columns here, and so we're going to start off with our x, follow it up with our y, and now we have our z column, right? So again, this is going to be a system using 3 variables here. So again, super easy to write out. We'll just go real quick with this. So negative 7x plus 2y plus 6z is equal to negative 1. That's my first row, so that's my first equation. The next row down, I got 4x minus 3y plus 4z is equal to 11. And then you'll notice here that in the x column here, I've got a 0, right? So we're actually not going to go ahead and write that variable in my system because you guys know as well as I do that that would just simply be 0x. And 0 times x would just make 0, or in other words, we wouldn't even write it in the problem, right? So we're just going to pick up with the y term there. So that'll be 5y minus 3z is equal to positive 7. And there is our system going along with that augmented matrix, okay? So again, it's going to be very, very important that we go ahead and pick up the skill of being able to kind of convert back and forth between a system and an augmented matrix, because in later videos and later lessons, we're going to be actually working with these matrices and using them to solve some systems. And so very, very important that we kind of get this terminology down about the order of a matrix and all these different types of matrices and that kind of thing, just so that we can use all these tools as we continue Chapter 7. But that's actually all I have for this video. Thank you very much for your attention. If you guys have any questions whatsoever, then as always, feel free to let me know. Thank you very much, and I'll speak to you in the next one.